I want to start today with a question. What do you think is more dangerous? One very large storm, or two storms that arrive back to back, one right after the other? Most people will say the very large storm. That answer feels intuitive. A bigger storm equals bigger damage. But in the world of meteorology and hydrology, the science of how water moves through the landscape, that answer is wrong. And today I'm going to show you exactly why, using real data from the Weather Prediction Center, the Storm Prediction Center, the Climate Prediction Center, and USGS stream gauges currently active across the affected states. Two storms are coming, and the second one, which on paper looks smaller than a historically major event, is going to produce impacts that could rival or exceed what a single record-breaking storm would have done. Because the first storm has already done something invisible, something you cannot see on radar, something that does not make for a dramatic satellite loop, but that changes everything about how Storm 2 will behave. It has filled the ground completely from the surface down to the water table. Across hundreds of thousands of square miles of the American South, the soil is at capacity. It cannot absorb another drop. And Storm 2 is about to drop a very large number of drops. Let me walk you through this from the beginning. Storm 1 is not dramatic. It does not have the cinematic quality of a hurricane or a tornado outbreak. It has no obvious, singular moment of violence. What it has instead is persistence. And in weather, persistence kills just as surely as intensity. The technical name for what we are dealing with is a stalled frontal boundary. A frontal boundary is the atmospheric dividing line between two air masses. On one side, warm and moist air streaming up from the Gulf of Mexico. On the other, cooler and drier air sitting to the north and west. Normally, fronts move. A cold front sweeps through your area, drops temperatures sharply, brings a band of heavy rain, and then exits to the east. Start to finish, it might rain hard for 8 hours. Then it is done. But sometimes, and this is the scenario we are dealing with, fronts stop moving. They stall. The steering mechanism that pushes them along, the large-scale wind pattern in the upper atmosphere, weakens or gets blocked by a ridge of high pressure. When that happens, the front sits, and it keeps producing rain in the same place, hour after hour, day after day. To put this in the most relatable terms possible, imagine a leaky faucet dripping into a bucket. 1 drip per second is not a crisis. But if you walk away and come back 7 days later, the bucket is overflowing, the floor is soaked, and water is seeped under the walls. That is what Storm 1 has done to the south. It has been the slow drip that nobody panics about in real time, but that has now produced a landscape in a state of maximum vulnerability. The Weather Prediction Center's multi-day precipitation analysis, a product that maps actual observed rainfall over the preceding days, shows a deeply concerning picture across Texas, Louisiana, Arkansas, Mississippi, Tennessee, and Alabama. Large portions of these states have received between 4 and 8 inches of rain from this stalled system alone. In the most concentrated areas, parts of the Texas coastal plain, the lower Mississippi bottomlands, portions of the Ouachita River Basin in Arkansas, observed totals have exceeded 10 to 12 inches. To contextualize those numbers, the average May rainfall total for much of this region in an entire month is between 4 and 6 inches. Storm 1 has delivered an entire month's worth of rain in a week, and now Storm 2 is arriving. While Storm 1 has been conducting its slow saturation of the south, a second and completely independent weather system has been organizing over the Pacific Ocean, and it is now moving east toward the continental United States with the same certainty as sunrise. This system is what meteorologists classify as a closed low. The distinction between a closed low and a weaker upper-level feature is not merely academic. It has direct, measurable consequences for the storm's intensity and the precipitation it produces. A weaker upper-level feature, called a trough, is essentially a bend or ripple in the jet stream. It can produce rain and even severe weather, but it tends to be less organized, shallower in the atmosphere, and it moves through an area relatively quickly. A closed low is something more powerful. It has a fully enclosed center of rotation in the middle and upper troposphere. Draw a map of upper-level pressure at 500 millibars, roughly 18,000 feet above sea level, and around a closed low, you can literally draw a closed circle around the center of lowest pressure. That enclosed structure means the system sustains itself efficiently. It drives strong upward motion over a large area. It carries significant moisture. And it produces heavy, organized precipitation over whatever it moves over. The Weather Prediction Center has this system in their quantitative precipitation forecast with significant rainfall totals, extending from the desert southwest and southern plains all the way through the Mississippi Valley. The Storm Prediction Center has independently flagged it for its role in setting up a severe weather outbreak along the dry line. Or the sharp boundary between Gulf moisture and drier western air where supercell thunderstorms tend to form. Crucially, the major numerical weather prediction models, the American GFS, the European ECMWF, are in strong agreement on the system's track, speed, and intensity. High model agreement on a significant system is one of the signals forecasters use to assess confidence. This is a high confidence event. There is very little scenario in which Storm 2 is a non-event. Here is the direct comparison to bring this into focus. Storm 2, if it arrived after a dry month in an otherwise normal year, would be a significant but manageable severe weather and heavy rain event. Parts of the southern plains and Gulf Coast would see flooding. There would be damage from severe thunderstorms. Emergency managers would respond and communities would recover relatively quickly. It would be a bad week of weather, not a catastrophe. But Storm 2 is not arriving after a dry month. It is arriving after Storm 1 has spent a week filling every river, saturating every field, and exhausting every natural buffer the landscape has. In that context, Storm 2 is not a significant weather event. It is a catalyst for a locally catastrophic hydrological disaster. The same storm, the same rain totals, the same track, but a completely different outcome because the landscape it is landing on is not the same. Before we go into the regional breakdown, there's a third element to this story that most viewers will not have heard about. And it may be the piece that elevates this from major storm week to violent and multi-hazard event. The Climate Prediction Center produces temperature anomaly maps, products that show how far current temperatures are departing from historical averages for the same time of year. The most recent CPC data for the northern plains is striking. Across North Dakota, South Dakota, Minnesota, and extending south into Nebraska and northwest Iowa, temperatures are running 20 to 30 degrees Fahrenheit above normal. Not 5 degrees, not 10 degrees, 20 to 30. To put that in concrete numbers, if the average high temperature in Fargo, North Dakota in early May is 62 degrees Fahrenheit and temperatures are running 25 degrees above normal, that puts afternoon highs at 87 degrees. If the average high in Bismarck is 60, add 25 degrees and you have 85. These are July temperatures in May. And they have been sitting over the northern plains for multiple days, not just an isolated afternoon. Here is why this matters so much for Storm 2. In the atmosphere, the energy available to drive storm development and severity is fundamentally linked to temperature contrast. The difference in temperature between the warm sector ahead of a storm system and the cold air behind it. The bigger the contrast, the more energy is available. The more energy available, the more intense and violent the atmospheric response when the two air masses collide along the frontal boundary. Think of it this way. Mix room temperature water with slightly warm water and not much happens. Pour room temperature water into a screaming hot pan and the reaction is immediate and violent. The same principle governs frontal weather. A front pushing into 65-degree air produces a different storm than a front pushing into 87-degree air over the same geography. The Storm Prediction Center, when assessing the risk for severe weather outbreaks, specifically evaluates this temperature contrast as part of the calculation for wind shear, the change in wind speed and direction with altitude. Wind shear is the ingredient that gives thunderstorms rotation. More wind shear means more rotating supercells. More rotating supercells means a higher probability of tornadoes, significant hail, and damaging straight-line winds. The Northern Plains heat anomaly is essentially turning up the dial on all of those parameters simultaneously. The SPC's elevated outlooks for the plains' severe weather threat during this event are not coincidental. They are a direct response to what the CPC temperature data is showing. Let me spend a focused moment on the most important concept in this entire video. Because if you walk away understanding one thing, I want it to be this. Compound flooding is not simply two floods happening close together. It is a specific meteorological and hydrological phenomenon in which the first flood event preconditions the landscape in such a way that the second event produces a response that is wildly disproportionate to what its rainfall totals would suggest. Here is the science. Soil has a property called infiltration capacity. It's its ability to absorb incoming rainfall. Under normal pre-storm conditions, healthy soil can absorb a substantial fraction of rain, commonly 40 to 60% in the humid south, sometimes more in sandy or loamy soils with good organic content. That absorption is your natural buffer. It is the sponge that sits between rain falling from the sky and water rising in your river. When the sponge is dry, it does its job. Rain falls. The sponge absorbs most of it. What is not absorbed runs off gradually into the drainage network. Rivers rise, but they rise at a rate the system can handle. After Storm 1 Nosworth, one has deposited 4 to 12 inches of rain over a week. The sponge is fully saturated. It cannot absorb another drop. Infiltration capacity drops to somewhere between 0 and 5%. What was a 40 to 60% buffer is now functionally gone. Now Storm 2 arrives and drops 3 inches of rain in 6 hours. Under dry soil conditions, that 3 inches would produce perhaps 1.5 inches of runoff, the rest absorbed. Under the saturated conditions that exist right now, that same 3 inches produces 2.85 inches of runoff. That is essentially the entire rainfall total running immediately into creeks, rivers, and drainage systems. The rivers were already at high levels from Storm 1. They were already running fast. Now they receive a second complete pulse of water, arriving faster than the first because the sponge is not slowing anything down. River gauges that were at minor flood stage jump to major flood stage. Rivers that were at major flood stage breach their banks. The USGS research literature on compound flood events documents this effect consistently. Studies show that runoff ratios, the fraction of rainfall converted to stream flow, can be 8 to 12 times higher in saturated antecedent conditions compared to dry conditions for identical rainfall inputs. The Weather Prediction Center incorporates soil moisture analysis into their excessive rainfall risk products, specifically because of this multiplier effect. When they assign a moderate or high excessive rainfall risk, as they are currently doing for portions of the affected region, they are accounting for this antecedent moisture problem. The practical meaning for people on the ground: a storm that would normally cause creek flooding in your area could now cause flooding that reaches up your driveway. A road that is passable in a normal heavy rainstorm could be under 3 feet of fast-moving water this week. The landscape is not normal right now. You cannot use past experience with storms as your guide. The baseline has shifted. Now let us apply all of this science to specific geographies and specific people. Texas Hill Country, the Edwards Plateau, and the hill country rivers draining it represent the single highest priority flash flood zone in the country during this event. This is not regional bias, it is hydrology. The limestone geology of the hill country is nearly impermeable. It sheds water off its surface quickly and funnels it into tight river canyons. The Guadalupe at Kerrville and New Braunfels, the Pedernales near Johnson City, the Llano at Mason, the Medina above San Antonio. These rivers can rise multiple feet in a single hour during a heavy rainstorm, under normal conditions. Under current conditions, with soil already saturated, the response will be faster and the peak levels will be higher. To compare, during the October 2018 hill country flooding, a storm that dropped 4 to 6 inches over 6 hours produced 30-foot rises on portions of the Guadalupe. That event occurred after a dry September. The current event arrives with the soil already at capacity. The flood response for equivalent or even lesser rainfall totals could be comparable or worse. What you must do: open the USGS National Water Information System website right now, waterdata.usgs.gov, and find the stream gauges on the rivers nearest to your location. Bookmark every one that matters to you. These gauges update every 15 minutes and give you the river level in real time. If you see a gauge rise 3 feet in 30 minutes, that is your signal to leave, before a warning is even issued, before the water reaches you. The time between gauge rise and flood arrival at downstream communities can be as short as 20 minutes on fast-draining hill country rivers. Know your low water crossings? In Kerr County, Gillespie County, Llano County, Comal County, there are hundreds of road crossings over creeks that are dry or ankle deep today and can be 4 feet of moving water tomorrow night. Drive those crossings now in daylight and decide in advance. If this crossing has water on it, I am not crossing it. Make that decision before adrenaline and inconvenience are pushing you toward a bad choice. Lower Mississippi Valley. Extended major river flooding. From Memphis, Tennessee, southward through the Mississippi Delta, and down the river corridor toward Baton Rouge and the Louisiana coastal plain, major river flooding is the primary threat from this event. It will not arrive as a flash. It will arrive as a slow, inexorable rise that continues for days after the rainfall ends. The Arkansas River, the White River, the Tallahatchie, the Yazoo, the Red River, all of these systems are already elevated from Storm 1. Storm 2 is going to add a second full pulse of water to each of them. The NWS Advanced Hydrologic Prediction Service, accessible at water.weather.gov, provides multi-day river forecasts, showing where each gauge is expected to crest and when. Floodplain residents along any of these rivers need to check those forecasts today, not the day the rain starts. Today, if your gauge is forecast to reach major flood stage, begin moving vehicles, equipment, and irreplaceable belongings above the projected flood level now, while roads are still clear and you have time. One specific comparison worth noting: the 2019 Mississippi River flood was a record-breaking, months-long event that caused billions in agricultural damage across the Delta. That event began with an unusually wet preceding fall and winter. The same compound principle applies. High antecedent moisture transformed what would have been a serious but manageable spring flood into a record breaker. The setup right now shares that same structural characteristic. Southern Plains, organized severe weather outbreak. For the Texas Panhandle, western and central Oklahoma, and southern Kansas, the primary threat from Storm 2 is not flooding. It is the severe weather that develops along the dry line as Storm 2's circulation pulls Gulf moisture northward and collides with drier western air. The SPC's elevated outlook for this area is driven by 3 converging factors. Extreme instability created by the northern plains heat anomaly, strong directional wind shear from the jet stream positioned overhead, and a sharp dry line that provides the trigger mechanism for storm initiation. That combination is what forecasters call a classic severe weather setup. And when all three ingredients are present simultaneously, the probability of a significant outbreak increases substantially. We are specifically watching for supercell thunderstorms. They're organized or rotating storms capable of producing tornadoes rated EF2 and above, hailstones 2 inches in diameter or larger, and straight line winds exceeding 80 miles per hour. For comparison, an EF2 tornado produces winds between 111 and 135 miles per hour, enough to cause major structural damage to well-built frame homes. Hailstones 2 inches in diameter are baseball-sized and fall fast enough to cause serious injury and total vehicles. For residents across the southern plains, today, not on the day of the outbreak, verify your shelter location. An interior room on the lowest floor of a sturdy permanent structure away from all windows. If you live in a mobile or manufactured home, a sturdy shelter plan is not optional. Those structures provide effectively no protection from a significant tornado. Identify a neighbor's basement, a school, a church with a basement, a community shelter, and know how long it takes to reach that shelter from where you live. Northern Rockies, late season snow and mountain travel hazard. On the northern flank of Storm 2's circulation, the interaction of Pacific moisture with the terrain of Montana, northern Idaho, and Wyoming will produce late-season snowfall at elevations above 5,000 to 6,000 feet. High mountain passes, including portions of I-90 through Montana, U.S. Route 2 through Glacier Country, and the Beartooth Highway, are at risk for abrupt road closures. This is the time of year when mountain travelers make the mistake of assuming spring means safe conditions. In the northern Rockies, in May, it does not. Check the Montana Department of Transportation and Idaho Transportation Department road cameras before any mountain travel in the next 4 days. Ohio Valley, heavy rain and urban flooding. Across Ohio, Kentucky, Indiana, and western Pennsylvania, Storm 2 will deliver 2 to 4 inches of rainfall in a relatively compressed time frame, a 24 to 36 hour window. For dry, healthy urban drainage systems, that would be manageable, though stressful. For the aging storm sewer infrastructure in cities like Cincinnati, Louisville, Pittsburgh, and Columbus, many of which rely on combined sewer overflow systems built in the 1950s and 1960s, it will produce localized but significant urban flooding. If you live in a low-lying neighborhood in any of these cities, know where your water goes. If your basement has flooded before, take protective measures before the rain starts. A sump pump that is working properly is the most cost-effective piece of flood protection for a residential basement in this region. I want to be explicit about the sources behind everything said in this video, because in an era when weather content ranges from rigorously sourced to outright sensationalism, you deserve to know where this information comes from. The Weather Prediction Center, wpc.nsep.noaa.gov, issues the excessive rainfall outlooks that assess flash flood risk by region. They incorporate soil moisture, antecedent conditions, and model-derived rainfall totals. Their Day 1, Day 2, and Day 3 outlooks are the most authoritative product available for assessing compound flood risk. The Storm Prediction Center, spc.noaa.gov, issues daily and outlooks for severe weather risk, with categories ranging from marginal through extreme. When the SPC places an area in enhanced or moderate risk, as they are doing for portions of the southern plains during this event, that represents a serious elevated probability of significant severe weather. The Climate Prediction Center, cpc.densep.noaa.gov, issues temperature and precipitation probability outlooks and produces the temperature anomaly maps showing the northern plains heat event that is fueling Storm 2's severity. USGS National Water Information System, waterdata.usgs.gov, provides real-time stream gauge data updated every 15 minutes for thousands of gauges across the country. For anyone near a river or creek in the Texas Hill Country, Mississippi Valley, or anywhere in the path of this event, this is your most important safety tool. NWS Advanced Hydrologic Prediction Service, water.weather.gov, provides multi-day river level forecasts at individual gauges, showing when rivers are expected to crest and at what level. This is where you find out if your specific river is forecast to reach minor, moderate, or major flood stage. These are not opinion sources. They are operational forecasting centers staffed by hundreds of professional meteorologists and hydrologists whose job every single day is to give you the most accurate warning they can with the best data available. When all of these sources are simultaneously flagging the same event with elevated risk products, that alignment is itself a signal. It is happening right now. Do not listen to these as suggestions, listen them as instructions. If you're in the Texas Hill Country, bookmark USGS stream gauges on your nearby rivers today. Know your low water crossings. If water is on the road, any amount, in any direction, turn around. You cannot judge the depth of moving floodwater by looking at it. You cannot judge the force of it. No road crossing during a flash flood warning is safe, regardless of how passable it looks. If you are in the lower Mississippi Valley, check your river forecast on NWS AHPS today. If your gauge is heading toward major flood stage, start moving property now. Clear roads do not stay clear once a river crests. The time to leave a floodplain is before the river rises, not during. If you are in the southern plains, enable every weather alert on your phone, both wireless emergency alerts and a weather alert app of your choice. Have your shelter location confirmed. Do not stand outside to watch storm development during a severe weather outbreak. The shelf cloud you see on the horizon can have a tornado descending from it that is not yet visible to the naked eye. For everyone in any affected area, the research is unambiguous. The leading cause of weather-related fatalities during flood events is vehicle submersion. People driving into flooded water on roads. 6 inches of fast-moving water can knock an adult off their feet. 2 feet of moving water will displace a full-size pickup truck. Turn around, don't drown. It is the simplest and most life-saving directive in all of emergency meteorology. 2 storms, one that has been patient and persistent, saturating the landscape for a week. One that is arriving with full energy into a landscape with zero remaining capacity to buffer its rainfall. The science says this is a compound event. The official data from WPC, SPC, CPC, USGS, and NWS all confirm this is a significant multi-hazard weather crisis for large portions of the United States. And the most important thing I can tell you is this. The time to prepare is right now, while roads are dry and clear and you can think without stress. Not when the rain is already heavy, not when the gauge is already jumping. Now, monitor your official local National Weather Service office, bookmark your USGS gauge, confirm your severe weather shelter, make your evacuation plan before you need it. I will be updating this forecast daily as Storm 2 approaches and the event evolves. New model runs every 6 hours will sharpen the regional details. Come back for those updates and share this video with anyone you know living in an affected area. Be safe, be prepared, and take this seriously.